Okay, for those of you who are gone for FFA and whatever else you're gone for, this is section 9.3, and we are on the second page. 9.3 on the second page. So they're starting us off with power reducing, okay? What does it mean to reduce a power?
Make it small.
Make it smaller, like sine squared and cosine squared. This is what they are equivalent to. Sine squared, cosine squared equivalent to that. These power reducing are right here at the bottom. So maybe put a star by him so that you know where he is located. We now have these. These are the power reducing, so you can refer back to this guy. The only difference is on your unit circle they call them u's instead of x's, but they mean the same thing, right? Okay, they're just using a different variable. So sine of u is 1 minus cosine of 2x or 2u all over 2. Cosine is 1 plus cosine 2u over 2. Okay, that's what those guys are. They're on your unit circle all together, so there's that. They want us to, in example 4, they're testing, I told you this yesterday, they're testing your knowledge of how you break things down and if you know how to do algebra, basically. This is like advanced algebra. Sine of 4x, or sine to the 4th power of x, okay? We want to break that guy down, but the only thing that I know is sine squared, okay? So we kind of have to rewrite him a little bit differently to start with. Sine to the 4th power x, we need to break him down to start with before we start plugging things in. Okay? Sine to the 4th is, what's your question? It doesn't matter. Whatever makes more sense to you. Yes, whatever makes more sense to you. So this guy, if I only know what sine squared is, this is kind of like sine squared x times another sine squared x, right? That's what sine to the 4th power is. We break it down, okay? All right, now I can plug that junk in for sine squared. Because what we're trying to do is we're trying to get rid of exponents. I want to get rid of exponents. And even though this formula for sine squared is uglier than what it was to start with, it will help me get rid of some exponent things, okay? So there's that. All right, so over here, if I plug this guy in for both of those pieces, I have 1 minus cosine 2x over 2 times 1 minus cosine 2x over 2.
I win.
So there he is, okay? And now I want to combine stuff, okay? So I want to multiply. I'm going to multiply this thing through. On the bottom, my bottom number is 4, yeah? Okay, 2 times 2 is 4 on the bottom. That's the easy part. What do you have to do at the top? Foil, right? Those are 2 pieces. So we're going to foil this guy times this guy, okay? All right, 1 times 1 is 1. Okay, that's the easy part. 1 times negative cosine 2x. Negative cosine 2x. Okay? Negative cosine 2x times 1 is another negative cosine 2x. And what is negative cosine of 2x times another negative cosine of 2x?
Cosine of 4x.
Positive.
Cosine 4x.
It's not cosine 4x. It's cosine squared 2x. Right? Cosine squared is what it means. Yeah. Okay? The insides you do not multiply together. The insides you don't multiply together. Because like for example, cosine of x times another cosine of x, right? Okay? Is not cosine of 2x, right? Even though there's 2 of them, that's not cosine 2x, right? Okay? It's cosine squared x, right? Okay, so that's how that breaks down. So think about it in terms of that. The 2x stays the same, but it's now cosine squared. Okay, so now we can put stuff together a little bit. 1 minus, these 2 pieces are the same, and there are 2 of them. So what does that look like? 2 cosine 2x. There's 2 of them, so 2 out in front. Plus cosine squared. Cosine squared 2x all over 4. Okay, what a stinky mess. Okay. Because these are adding and this was multiplying. Yep, good question. Okay. All right, now let's see if we've answered their question. Okay. Can we take out a 2? No. Because these 2's are trapped inside of the cosine. And 1 doesn't have a 2 to take out anyway. So, yeah, good question. Okay. We want to write this in terms.
Then you have half minus.
Oh, yeah, that sucks.
We want to write this in terms of constants and first degrees of cosines and sines. Do we have everything in the first power? Do we have everything in the first power? No, we don't. We have this guy. Cosine squared of 2x. Yeah, cosine squared of 2x. Okay, now. This guy is what we're going to focus on now. Okay? We're going to break him down. And we have a formula for him. Okay? We have a formula for him. So, this is going to get kind of messy. Sorry. In place of this guy, I'm going to put 1 plus cosine of 2x over 2, except, okay, be careful of this. Watch this really carefully. Cosine squared x is this guy, right? Okay? But we have 2x here in this spot. Oh, no.
No. It's the last question.
Okay? So basically in here we're saying that 2x is the x, and this is 2 times that value.
4x, right?
So this guy will be 4x inside of here. Does that make sense?
It's not easy.
Yeah. So when you're doing cosine squared 2x, this becomes a 4x inside of here, right? In the formula. Yeah? Yeah.
If it was a 3, it would be 6.
Yeah.
If it was 3, it would be 6, 4, 8.
Yes. Mm-hmm. Right. If it was 3, it would
Right,
be 6.
You're
If
so
it was
smart.
4, it would be 8. Yeah, exactly. Okay, so that's what he will look like. Yucky stuff. Yucky stuff. Okay. All right, let's do this. All right, I'm gonna write down here. No, I'm gonna put them all. I'm gonna write down here. Okay.
What are we doing?
I'm gonna write them all the way down here, so we see what we have on the top. This is what we have on the top. Watch this carefully. What we have on the top is 1 minus 2 cosine of 2x plus 1 plus cosine of 4x over 2. And on the bottom, all the way across the bottom, we have 4. Okay? Now, I'm going to do this a little bit different. That's the top part, right? If we are dividing by 4, this is like dividing by 4 over 1, right? Dividing by 4 over 1. We can take this entire thing and we can multiply him by 1/4. Does that make sense?
Yeah.
We can multiply him by 1/4, the entire thing. So the 4 over 1, if I flip him to the top, I can take the top part times 1/4. Then we're just going to distribute him through and be done. Okay? So 1 times 1/4 is 1/4. What is 2 times 1/4?
0.5.
1/2. Okay, do you distribute the 1/4 times this 2 also? No, just the numbers out in front. Okay? All right. And then this stuff all on the top, 1 plus cosine of 4x, that's being multiplied by the 1, but the 2 on the bottom is multiplied by the 4, so that's over 8. Does that make sense? That's kind of disgusting. Okay, do you see what we did? 1/4 times this, 1/4 times this, 1/4 times that, yeah? Okay, 1 on the top doesn't change the top, but the 2 on the bottom is going to become 8 now. Okay, now, let's see what we have. They asked us to write this thing in terms of constants and first powers of cosine functions and sine functions. Is this in terms of first powers of cosine functions? Even though there's 2's and 4's and junk in there, it is first powers. So this is where we're going to leave him off at. That is disgusting, but that's okay. Yeah.
So makes more sense than lost. Why wouldn't you keep it inside?
I don't know.
None
Why
of
is
this
it,
makes
why
They
is
don't
this
wanna do
conversion
powers.
necessary?
I don't know. They just want to see if you know how to do this for algebra. You will not have to do something this advanced for your homework, but they just want to see if you know your algebra. So practicing it now will like help you later on when you see something that's like half this difficult, right? Okay. All right, now half angle identities. Okay. Sine of x divided by 2, cosine of x divided by 2, those type of things. Half angle identities. I don't have a. Let's see. I don't have a pi over 12 on my unit circle. Listen to this. I don't have a pi over 12 on my unit circle. So this is why a half angle identity is important. Okay? To get to pi over 12, I can use something divided by 2 to get to pi over 12. Okay? What divided by 2 will give you pi over 12? Okay? So what I can do is I can write sine of pi over 12 as sine of pi over 6 divided by 2. Does that make sense? Pi over 6 divided by 2 is the same thing as pi over 12. Do you have a pi over 6 on your unit circle? You betcha. Okay, so this is why this half angle identity is important, because I have those things on my unit circle. Pi over 6 divided by 2 is pi over 12. Okay? Now, in this case, I want you to write out, since we're writing it as sine of x divided by 2, in this case down here, what would the x be? Pi over 6. So x I have converted to pi over 6. Do you see how that works? Watch this. Listen. Right. Go.
Yep.
Okay. So sine of something divided by 2, that something or that x is my pi over 6. Yeah?
Yep.
Okay. So now I want to write out the formula. Okay. And this is what the formula says. Plus minus. We'll get to the plus minus here in just a second. 1 minus cosine of x. But we know what cosine of x is, or we know what x is anyway. X is pi over 6, okay, divided by 2. All right? Does this make sense? We are rewriting pi over 12 as pi over 6 divided by 2, because I have a pi over 6. I don't have a pi over 12. I have pi over 6, but not pi over 12, okay? So, now, in this formula, from this point, I can figure out what cosine of pi over 6 is. Go to your unit circle. Unit circle. Pi over 6 is here. Cosine is square root of 3 over 2. Yeah? Okay, so this thing gets knocked out, and this is equivalent to the square root of 3 over 2. Yeah? That's what he is equivalent to. Good, good?
Yep.
Okay, now on the top, I have 1 minus the square root of 3 over 2. Yeah? And I all over 2. But I want to find a common denominator here. So I'm going to make this 2 over 2 minus the square root of 3 over 2. Yeah? Okay, so on the top, I have 2 minus the square root of 3 all over 2. If I write them under one roof, are we confused? No? And that's all over 2, right? That's underneath of this radical thing, plus, minus, whatever, blah, blah, blah. Okay? All right, now what? Yes, the bottom. 2, this is 2 over 1. And I'm going to multiply him by 1/2. Yeah? Okay? So, this entire thing is going to be the square root of 2 minus the square root of 3 times 1, which stays 2 minus the square root of 3, all over 4. Okay? Good, good? Yes, yes? Okay? Now, one more thing. It does not stay plus or minus. We have to decide if it's going to be positive or negative. Okay? We have to decide whether it's going to be positive or negative. So, looking at the original, here's the original. This original guy, or original, what quadrant will pi over 12 be in? He will be in the first quadrant. Sine of something that's in the first quadrant will be positive or negative. Which one? He will be positive. So, that's how I decide this. This is what he will look like. Okay? All right, now, you don't necessarily have to write this down. You can if you want to. The book will put this as the square root of 2 minus the square root of 3 all over 2. You see what they did? Since the square root of 4 comes out nicely as 2, they just put the square root to the top and put the bottom as 2. Does that make sense? Okay. If you write it like that, I do not care. If you write it like this, I do not care. They're both correct. The book just likes to simplify it like this. Yes?
Yeah.
Good, good? Okay. All right, so you look at the original to decide whether it's plus or minus, yeah? Okay, cosine. 5 pi over 8. Do you have a 5 pi over 8 on your unit circle? You have a 5 pi over... Okay.
5 pi over 4.
5 pi over 4 divided by 2, right? 5 pi over 8, I do not have on my unit circle, but I do know that if I take 5 pi over 4 and divide by 2, that will give me 5 pi over 8, yeah? Okay? Good, good? Yes, yes? Okay, so in this case, what is x equivalent to? The x that I'm using is 5 pi over 4. Okay, let's do this really quick. Let's choose whether it's plus or minus. 5 pi over 8.
Minus.
Do you know what quadrant 5 pi over 8 lives in? 5 pi over 8 is in the third quadrant, or 5 pi over 4 is in the third quadrant?
No, it's in the third.
Okay. 5 pi over 4, if you don't know what that is, 5 pi over 8, or excuse me, if you don't know what 5 pi over 8 is, you can multiply by 180 over pi and figure out what the degrees are. So pi's cancel out. What's 5 times 180 divided by 8? How many degrees is that? How many degrees is 5 pi over 8? 112.5. Okay, I don't have a 112.5 on my unit circle, but I do. Oh, why did I put percent? Degrees. 112.5, what quadrant is he in? He is in quadrant 2. And cosine in the second quadrant is negative. So when I'm doing this formula up here for cosine of x over 2, I am going to use negative square root of all of that junk, right? Okay, good, good? Okay, that's how I decide what positive or negative, all right? The formula up here for cosine of x over 2 is 1 plus cosine of x all over 2. Yeah? Okay. X is, what did we say x was? 5 pi over 4. Okay? All right. So now we can find what cosine of 5 pi over 4 is. Look on your unit circle, find 5 pi over 4. Cosine, oh, disgusting. Negative square root of 2 over 2. That's what cosine of 5 pi over 4 is. Okay? All right. So on the top, we have 1 minus the square root of 2 over 2. And I want to combine those two things. Okay? Okay, so it is, you're right. It is 1 plus a negative square root of 2 over 2. Good thought. I kind of skipped over that. 1 plus a negative square root of 2 over 2. I'm going to change that to minus. Can I do that? Okay. I kind of snuck that in there. So I'm going to change this to 2 over 2. So this guy on top will look like 2 minus the square root of 2 all over 2. Yeah? Okay? And on the bottom, my bottom number is 2. Then what? But then this is 2 over 1, which I can keep flip to the top to make it times 1/2. All right? So negative square root 2 minus the square root of 2 all over 4. There he is. Boom. All done. Okay, yeah, 1 became 2 over 2. Questions about that? That's kind of messy. But just, they're saying if you can do your algebra correctly. Okay? All right? Okay? Good, good? Now, these ones are nicer, actually, I think, than half angle. Okay? All right, last couple ones over here. This is tangent. Okay? And this one, they give me numbers. Okay, so these are going to be, this tangent is going to be kind of like your 13, 14, 15 on the homework assignment. It's going to be exactly like this. This is number 13 through 15. It's going to be exactly like this problem. This one is tangent. You have to do all 3. Okay? So, when they give me this information, I'm going to draw what he looks like. I'm going to put him over here, and I'm going to draw what he looks like. This tells me what quadrant he's in. Pi to 3 pi over 2. What quadrant is that? Pi to 3 pi over 2. Pi lives here. 3 pi over 2 lives here, so he is going to be in the third, right? Okay? We know that tangent is 3 over 2. And tangent is opposite over adjacent. Okay, so the opposite side is 3, the adjacent side is 2, yeah?
Negative.
And they are both negative, right? Yeah. That's why it's positive, 3 over 2. But we need to insert the negative, so both negatives, 3 and 2. Square root of 13. 3 squared will be 9. 2 squared will be 4. 9 plus 4 is 13, so this guy will be the square root of 13 if you do it in your head. Yeah? Otherwise, write it all out. Okay? If you can't do that in your head, write it all out. 3 squared is 9, 2 squared is 4, 9 plus 4 is 13, take the square root. Yeah? And that's never negative, right? Okay, so tangent of x over 2, I'm going to use one of those two formulas. It doesn't matter which one. Which one would you like to use? Which? The plus, the bottom one? The bottom one? Sure. Let's do the bottom one. Okay? So, tangent of that one, I need to do sine of that thing. I'm just going to rewrite. Sine of x, 1 plus cosine of x. Okay? And we're going to plop our numbers in. Okay? So, this angle right here, what is sine of that thing? Sine is opposite over hypotenuse. Opposite hypotenuse. -3 over the square root of 13. Yeah? Okay? The other one is 1 plus cosine of x is adjacent over hypotenuse, so -2 over the square root of 13. Yeah? Okay. This is actually going to come out fairly nice, I promise you. I need to, on the bottom, get a common denominator. What's my common denominator on the bottom? Yes, so how do I change 1 to be a square root of 13? It'll be the square root of 13 over the square root of 13. That's what reduces to 1, right? Okay. So, on the top, I have -3 over the square root of 13. On the bottom, I have square root of 13 minus 2 over the square root of 13. Okay? Right, this comes out really nice. I don't know if you can see it yet. Can you see it yet? Keep, flip, flip. Right? So the top bar is going to be kept times the square root of 13 all over the square root of 13 minus 2. And, ta-da! The square root of 13's cancel out. These guys. Right? Okay? Are we doing okay so far? Okay? So the whole thing comes out to be, what's on the top? -3, square root of 13, minus 2, and that's what he is. Wow, that's still ugly, but it came out a lot nicer than it was to start with, right?
Couldn't you technically leave it and then do 3 square root of 13 and then 11 on the bottom? No, it's 4
Oh. Yeah, if you rationalize,
Yeah,
is that what you're talking about?
but you have to foil it.
Yeah. You would have to foil. It wouldn't quite be that way, but it would be something like that. Okay, good? Like this? Yes? All right, product to sum and sum to product. Okay, check out what they're doing here. These two right here, sine times cosine. Sine, cosine written together. Put it away. Go sit. I shouldn't have to tell you to sit down. Now put your stuff away. Do it. Okay? Sine, cosine is a product. Okay? They are taking that product and they're turning them into a sum, which means you're adding them. Yeah? That's why this is product to sum. Okay? This one right here is a sum to product because you're adding here. So this is a sum. You're adding. And now I am making them a product because sine and cosine are written together. Product. Okay? Sum to product or product to sum. Right? It's another way of breaking these things apart. Okay? Again, we're testing our knowledge of how much algebra that we know, and there's that. Okay? All right. So, we're going to start with the left side of this, and we're going to start with the top on the left. Okay? So, sine of t plus sine of 3t. This is going to be similar to your homework assignment, exactly like number 4, 5, and 6, except you just have to do single pieces. Okay? They don't have a bottom to this, so compare these two. There's sine of t and sine of 3t. You're doing sine of 3x, sine of 5x, and you're adding those together. So what we're doing right here is going to really translate to what you're doing on 4, 5, 6. They're going to be really similar to each other. You're putting them together, okay? So kind of take note of what we're doing over here. Here's how this works. This is a sum, and we want to try to write it as a product, okay? All right, so sum to product. We're doing sine of something plus sine of something else. So which one of these 4 are we using? The first one, okay? Sine of x plus sine of y. In this case, what is x? X is actually equal to t. Y is actually equal to 3t. You see how that works? Yeah? Okay, so this guy right here, we want to write him, and this is what we're replacing him with. It looks really ugly to start with, but I promise you it will come out nice, okay? Okay, so we're plugging stuff in. So this top part is 2 sine of x plus y over 2 cosine of x minus y over 2. Okay? All right, so sine of x plus y over 2 is like t plus 3t. Yeah, x plus y. All right? Now, cosine is x minus y. That's what the formula says. So I have t minus 3t. Yeah? Good, good? Okay? That's what that top part is. Okay? So let's simplify that top part really quick. So 2 sine of, this would be 4t divided by 2, which is just 2t. Ah. Nobody's laughing. Okay, whatever. Ah. T minus 3t is negative 2t divided by 2, which is negative t. I'm going to put the negative t in parentheses so it doesn't look like we're subtracting. Okay? So cosine of negative t, that's what the top part breaks down into. A little bit nice, maybe. We have gone from our sum to a product. Okay, that's what it'll look like. Okay, now we got to do the bottom and see if it cancels out. So this bottom part, I'll do the bottom in a different color. I'll do the bottom in orange. Okay, so bottom here. Okay, again, we still have x being t and y being 3t, yeah? Okay, and this is cosine plus cosine. So which one of the three are we doing up, or four are we doing up here? The third one. We're doing this guy. Okay, all right, so that guy on the bottom is 2 cosine of x plus y over 2, cosine of x minus y over 2. Okay? X plus y over 2 is t plus 3t. X minus y is t minus 3t. Okay? We're just popping those numbers in for x and y, yeah? Okay? All right. We will simplify him. So 2 comes out like this. Cosine of t plus 3t is 4t divided by 2, or 2t. This one is cosine of t minus 3t, or negative 2t over 2, which is cosine of negative t. All right? And now beautiful things happen. Okay, I'll let you get to this point. We're trying to get to this point. We're trying to get to this point, okay? Do you see how it makes tangent? Okay? The 2's are going to cross out. The cosines are going to cross out. So I have sine of 2t over cosine of 2t, which is tangent of 2t. Ha ha ha. There you go, done. Okay, check. Now, on your homework assignment, keep in mind, it's very similar to this one, except you are only doing one of them, right? You're only doing like the top or the bottom, okay? So this one, just note here on 4 through 6, what are each of these? What is this chunk and this chunk and this chunk? Those are sums. And so you are going sum to product on these, okay? All right, so that's what you're doing on 4, 5, 6. On 1, 2, 3, what are those?
Those are products.
Those are products. And you are trying to convert them to a sum, yeah? So those are the formulas that you are going to use. Yeah? Okay? All right, good? There you go. This one right here, use a half angle identity. They tell you which one to use. Half angle identities, okay? Just so that you get a start. Should we start you out on the first one?
Sure.
Okay. I don't have a 3 pi over 8.
Let's do one.
Hold on. Okay, but I want to write this as sine of x divided by 2. So what divided by 2 will give me 3 pi over 8? 3 pi over 4 divided by 2. That's what that first one will look like, number 7. Yeah? Okay? All right. 8 and 9 will be similar to that, yeah?
Yeah.
Okay? Number 8 is cosine of what divided by 2? 7 pi over 4 divided by 2. Yeah? Okay, what about tangent?
Pi over 2 divided by 4.
Pi over 4 divided by 2. I think you said that in reverse, yeah. Okay, pi over 4 divided by 2. So, in each one of these, your x's will be the top number. X is 3 pi over 4, 7 pi over 4, pi over 4. Because I have those on my unit circle. I don't have the other pieces, yeah? Okay, so there's that. This won't be too bad. I promise. Just do your algebra correct. All right, there you go. That's it.
Did we just do them all?
No, you got to actually do the thing.